Okay, welcome back. This is part three of really understanding the most simplified way of understanding schematics. Like we just went over all the parts of the schematics. Now we're going to deal with a little technicality of it, which is the voltage drops. That's the hard part of it. Now, there's a rule. Voltage drop. From here across a component is called a voltage drop. Sometimes we can lose voltage across a component. The rule is, so you understand, we don't lose any voltage drop across a fuse or a piece of wire. Here is a piece of wire. Here is a piece of wire between here and here. We don't lose any voltage. Here is a piece of wire from here to here. We don't lose any voltage. From the fuse itself, one side we should not lose any voltage. Now, with that rule in stake, let's try to understand voltage drops and voltage points references. We know 12 volts is our battery. You know that. At one side of this fuse, number 41, it's 12 volts because it goes through a wire. Like our rule just said, we don't lose any voltage. 12 volts here, 12 volts here. Again, how much over here? 12 volts. Why? We don't lose any voltage across a low resistance fuse. If we go over here, how much over here then? 12 volts. Why? Because we should not lose any voltage through this wire and through this fuse. So far, 12 volts, we didn't lose anything, correct? 12 volts here. Let's just go over this one. 12 volts over here. 12 volts. Why? It's just a wire. Doesn't matter the color of the... No, I don't care what color wire it is. We shouldn't lose any voltage through it. How about ignition switch? I put 12 volts here. I put 12 volts over here. Why 12 volts? It's just a switch. Let's go over here. Remember we talked about this one. How about this one? 12 volts over here, 12 volts over here. Why? It's just a switch. So if you want to know if the ignition switch is good, go to the other side. You should have the same 12 volts here, 12 volts there. Now, continuing here. We go through here. We go through another fuse, through another wire. Same thing, 12 volts. How much other side of the fuse? Same rule applies. No voltage loss. 12. This is low resistance, less than an ohm. 12, and then here, 12 volts. The other one, same thing. 12 volts here, 12 volts here, 12 volts here. Why? It's a wire. How much over here? 12 volts. How much over here? 12 volts. Go this way. How much over here? 12 volts. Why? Just a fuse. 2 fuses. Doesn't matter. 2 fuses, 3 fuses, 4 fuses. Doesn't matter. Doesn't matter. Which one will pop first? If I have something and it's 35 amps, which one will pop? It depends where it's connected to. If this is 35 amps, something that's connected to this, it draws more than 30 amps, let's say 32 amps, 33 amps, this one will pop. Not this one, it's not connected to it. Not this one, it's not connected to it. For this one to pop, you need more than 80 amps, maybe 82, 83 amps. It'll pop the first one, and that's it. It won't make a difference. So if it pops, this will be 12, and this will be 0. Doesn't matter what these two are. This will pop first. Now, 12 volts over here, 12 volts over here into this what? B2. Just a fuse, just a wire. Just how about in the switch? Did we lose anything? No. 12 volts here. And how much over here at B1? 12 volts here. And over here at the other side of the fuses, how much? 12 and 12. Going to whatever lights there are. How about over here? Same scenario. 12 here, 12 here, 12 here, 12 here. 12. How about this switch? How about this switch? We have 2 switches. Do I lose any voltage? 12 volts here, 12 volts here, and 12 volts over here. It's just switches, low resistance. How about over here? 12 volts here. So I think you get the idea. You don't lose voltage through any switches, or any fuses, or any wires. You're just going to lose voltage through a bulb. That's how you lose voltages. So remember that rule. I hope this was instrumental. And here, so let's say we're going to have 12 volts over here. 12 volts through the fuse. Whatever goes into the fuse should come out the same. Whatever goes into the switch, the voltage should come out the same. If 12 volts went in, 12 volts has to come out. If 12 volts goes in, 12 volts has to come out of that fuse. And it goes to high beam. How much over here? I said 12 volts over here. How much over here? If you said 12 volts over here, no. No. It is 0 volts. This is connected to ground, remember? This is ground. Where is the whole 12 volts across? This bulb. Where is 12 volts over here? 0 volt. Where is the 12 volts across? This one. What about these? Are they any more different from these? Nope. It goes to ground. Which side is 0 volts? This side or this side? If you said this side, you're correct. How much is this side? 12 volts. We lose the whole 12 volts across this little thing, the bulb. I'm the only channel, to be honest, that I put the voltage drops. You don't see this, and there are quite a few channels out there with how to understand wiring diagrams. But I take the preparedness and make sure that you understand and label every point with voltages so you understand. And it's amazing to me that I've had emails from people working in dealerships and all that. They refer to my schematics, not this one obviously, a regular schematic with the voltages, that they refer to those as a reference. It's amazing. But that if that helps, whatever helps the viewers. If it simplifies it, hey, it's all right. Just takes a little more time for me, but as long whatever helps and can be absorbed. I hope this was helpful. Please go and give me a like, and please give me a subscribe to Automotive Electronic Schematics. I need about 170 more subscribers. It's a different channel. And my other one, Joe Electronic Schematics by Joseph. Joe Electronic Schematics for Auto. And the other one is Automotive Electronic Schematics by Joseph. So please subscribe to both if you want. Hey, why not? Please give likes for both, whatever. But anyway, please join. Thanks.